and welcome to a discussion on threat and error management applied to loss of control in flight. I'm David Carroll, the Director of Training Programs at Aviation Performance Solutions. My background is 25 years as an Air Force fighter pilot flying the F-15 and A-10, as well as instructing in the T-38 at the undergraduate and pilot instructor training levels, as well as 3 years of upset prevention and recovery training in the Extra 300 for a total of about 1,400 hours at this point. I also have a master's degrees in aviation and currently working on a PhD in aviation and aviation safety and human factors with Embry-Riddle Aeronautical University, expecting to be complete in 2016. We're going to talk about the risk of loss of control in flight, define what upset prevention and recovery training is, discuss threat and error management, identifying threats, errors, and undesired aircraft states, and discuss how we're going to integrate upset prevention and recovery training and threat and error management. So first, loss of control in flight risks. Loss of control in flight does remain the leading cause of fatalities in commercial and general aviation. The air transportation industry and national aviation authorities have begun to make reducing loss of control in flight mishaps a priority. The National Transportation Safety Board identified reduction of loss of control in flight as one of their top 10 priorities. Airline manufacturers, the ICAO, the FAA have all released guidance pertaining to loss of control in flight prevention and preferred training methods. The Airplane Upset Recovery Training Aid, a joint publication by Boeing, Airbus, and the Flight Safety Foundation, was released in 2008. The ICAO document 10011, Manual on Aeroplane Upset Prevention and Recovery Training, was published in 2013, and the FAA's AC 12111, Upset Prevention and Recovery Training, was published in April of 2015. All of this attention was due to a number of high-visibility aircraft accidents that were related to loss of control in flight. To show how prevalent it is, let's look at the statistics provided by the Commercial Aviation Safety Team. This is a chart showing the fatalities by cause in the worldwide commercial jet fleet from 2004 through 2013. The categories listed here, 11 of them out of the total, are the only ones that had fatal mishaps during the period. As you can see on the upper right side of the chart, there's a significant number of areas that they did not note any fatal accidents. However, loss of control in flight once again led the total by a significant margin. What is the risk of being an onboard fatality in relation to loss of control in flight? Well, we can see the loss of control in flight is the leading factor, with controlled flight into terrain being second by a long shot. As well, runway excursions on landing, as well as abnormal runway contacts and undershoots and overshoots, those are about the same amount in each category. You're still twice as likely to die from a loss of control in flight mishap as from a controlled flight into terrain incident or a runway excursion on landing. Further, if we go past the unknown into some system component failure power plant, an engine failure, or mid-air collision, those mishaps have similar numbers of fatalities. You can see you're 10 times more likely to have be a fatality from a loss of control in flight as you are a engine failure or a mid-air collision. If we look at wind shears and thunderstorms, 16 times more likely to be a fatality from a loss of control in flight. And if we go all the way down to non-impact related fires, you're 380 times more likely to perish from a loss of control in flight mishap as you are from a non-impact related fire. Fully 40% of all commercial worldwide jet fleet fatalities are related to loss of control in flight. So loss of control in flight or an upset can be prevented or recovered from with proper training. But what is an upset? Well, upset recovery training is specialized training focused on mitigating the loss of control in flight threat. An upset, defined by the various documents, is more than 25 degrees pitch up, more than 10 degrees pitch down, or greater than 45 degrees of bank angle, or being within those parameters but at an inappropriate airspeed. Those parameters bound the green area in the chart, and you can see that's a very small portion. Matter of fact, slightly less than 5% of the full flight envelope. Most pilots spend most of their career in significantly less area, going no more than 30 degrees of bank and 10 degrees nose up and nose down for most of their flying career. But what do we train them to? Well, most regulatory required training to get your license demands no more than 30 degrees pitch up, 30 degrees pitch down, and 60 degrees of bank angle, the yellow area in the chart. Although we have more than doubled the area of exposure, up to 11% now of the envelope, we can see it's still significantly less than the full flight potential of the aircraft. What's the aircraft capable of? The full flight envelope of 90 degrees pitch up, 90 degrees pitch down, 180 degrees of bank angle in either direction, the red area in the chart. The aircraft is free to experience the entire full flight envelope during an upset. And many pilots have never been in that envelope, that portion of the envelope, and have no idea how to recover the airplane or how to fly the airplane from that situation. Upset prevention and recovery training, there are generally three categories, starting with awareness training. Many pilots have never experienced the G loads and pitch and bank angles associated with aircraft upsets. Awareness training presents the core concepts of UPRT as well as exposing pilots to the sights and sensations of the aircraft in an upset in a building block approach that builds confidence in the training while minimizing the likelihood of the pilot in training becoming overwhelmed. The next category of UPRT is recognition and avoidance, which can be further divided into time favorable and time critical. Time favorable situations allow the pilot to use aeronautical decision making to manage the outcome. These scenarios provide the pilot with the time necessary to plan for mitigation or avoidance of the threat. For example, while still 30 minutes from arrival, reports from the destination airport indicate strong wind shear associated with thunderstorms. The pilots could hold until the storms pass or elect to proceed to the divert location. Either are valid strategies that would avoid a potential for loss of control in flight event. Time-critical situations require immediate, sometimes on the order of mere seconds or less, to respond to the divergence from desired aircraft state. Recognition and recovery becomes necessary when the aircraft exceeds the parameters defining an aircraft upset. Immediate application of appropriate recovery strategies and techniques is critical to safe recovery of the airplane. Generally, building block sequence addressing recovery phase of skill training has shown to impart long-lasting skill sets in pilots while maximizing the understanding of prevention and recovery mitigation within the widest range of fixed-wing airplane operations. End result of comprehensive upset recovery training program is to arm pilots with enhanced awareness and skills that are generally transferable and effective with due consideration for type-specific variations. In accordance with FAA AC 120-111, the goal of UPRT is to provide for pilots to demonstrate knowledge and skill in preventing, recognizing, and if necessary, recovering from an upset through a train to proficiency methodology. Effective UPRT programs are multimodal, comprised of academics, on-aircraft, and simulator training mediums. The ICAO Manual on Airplane Upset Prevention and Recovery Training provides fairly detailed guidance on the content of each phase of training. Manual also describes a training path that moves from academics to on-aircraft training to non-type-specific flight simulation to type-specific simulator training. This progression allows the pilot to build knowledge from fundamental aerodynamics to application of mitigation and recovery strategies in their specific aircraft. On-aircraft training is critical as simulators are unable to accurately present the sensations necessary to develop the knowledge and awareness and experience in airplane upsets and unusual attitudes, and how to effectively analyze the event and then apply correct recovery techniques. The intent of UPRT is to provide pilots with the knowledge and skills necessary to recover from a loss of control in flight event, regardless of how severe the upset becomes. While the pilot should not wait for a predetermined pitch or bank angle to develop before initiating recovery, the pilot should be able to effectively apply the mitigation strategy from any flight condition. The figure here depicts this by showing an increasingly divergent bank upset. At any bank angle, the pilot should apply an appropriate strategy to return the aircraft to the desired attitude. Next, we'll talk about threat and error management, or TEM. Threat and error management is a concept developed by researchers at the University of Texas Human Factors Research Project that seeks to minimize safety risks, thereby maximizing safety margins through a proactive philosophy. The TEM concept is to have pilots consider not only the external influences that impact safety, but also to consider their own reactions to those influences as well as mistakes they make in the conduct of a flight. The consideration of both these factors is a distinct advantage of the TEM concept. Threats are those things outside the influence of the crew, those events, which increase flight complexity, requiring flight crew management and attention. This is a broad category encompassing many aspects of a flight. Threats can be further divided into expected and unexpected. Forecast weather, planned routing, high-density airport operations are all threats that fall into the expected category. Pilots can plan for these issues and plan defenses to accommodate them. Aircraft malfunctions, change routings, and unforecast weather fall into the unexpected category, and pilots must deal with these issues as they emerge. An additional threat that exists that are the impact of errors committed by others. Of note, to be considered a threat, the issue must complicate the flight. Threat management involves how pilots anticipate, prepare for, and respond to these threats. It's estimated that up to 90% of all threats are properly managed within airline operations, leaving about 10% of threats mismanaged due to or leading to aircrew errors. An error is any act committed or omitted by the pilots that results in a deviation from what they intended, reduces the margin of safety, and increases the likelihood of an adverse operational event. Procedural errors involve pilot divergence from policy, regulations, aircraft flight manual standards, or procedures. Examples include accidentally missing a checklist step or purposely omitting that step. Communication errors can be between the pilots or with those outside the cockpit. And finally, aircraft handling errors are identified as those involving skill or knowledge in handling the aircraft. Aircraft handling errors result in deviations of aircraft direction, attitude, velocity, and configuration. How pilots respond to an error directly impacts the outcome of the event. First, the error must be detected, as an error that is not detected cannot be managed. The error is detected and dealt with properly, it should result in what is known as a trap. The situation does not become serious. If the aircrew's action or inaction after noticing an error makes the situation worse, produces a negative outcome, that's considered an exacerbate. And a fail to respond is when the crew does not react because it either is not noticed or is ignored. 3 possible outcomes from an error, regardless of the response by the pilots, is an event that is inconsequential, has no effect on the safe completion of the flight. Could result in additional error. In responding to the noticed error, the aircrew makes an additional error that must now be managed in it as well, or it could result in an undesired aircraft state. Undesired aircraft state is a position, condition, or attitude of an aircraft that clearly reduces safety margins and is a result of actions by the flight crew. The error results in the aircraft being unnecessarily placed in a condition that increases risk. This includes incorrect vertical or lateral navigation, unstable approaches, a low fuel state, lining up for the wrong runway, and reduced separation. Simply being at the wrong altitude constitutes a undesired aircraft state. If deviations in pitch, bank, or airspeed become severe enough, the undesired aircraft state moves into a category of an upset, with an accident or incident resulting from the upset falling into the classification of a loss of control in flight. In response to the undesired aircraft state, the crew may resolve it safely and mitigate it. Their response may make it worse and they may exacerbate it, or if the crew fails to respond, it is categorized as a failed to respond. In any event, pilots can be trained to appropriately manage the undesired aircraft state through good UPRT. Undesired aircraft state outcomes: they recover the aircraft, they make an additional error, or an accident or incident. So how are we going to integrate threat and error management and upset prevention and recovery training? Pilots can significantly increase flight safety by integrating upset prevention and recovery training considerations into their TEM process. By including the threats that can result in a loss of control in flight event, during the flight planning phase, they can develop plans that avoid those threats. By keeping loss of control in flight threats in mind during the conduct of a flight, they'll be more likely to recognize the precursors to a loss of control in flight and take early action to prevent a loss of control in flight occurrence. Should a loss of control in flight event happen, having participated in quality UPRT programs should have imparted the skills necessary to recover the aircraft. Threats that can be anticipated should be taken into consideration during flight planning. Forecast weather that includes thunderstorms, wind shear, or icing all fall into this category. Wake turbulence also has a component that falls within this category. If the flight plan includes operations in areas where heavy aircraft traffic is expected, pilots should take this into consideration during planning. A possible mitigation strategy in this situation may be to select an alternative destination, such as a nearby reliever airfield, that still meets the objective of the flight. The pilot with an awareness of preceding traffic, the airfield winds, and the dynamics of wake turbulence can plan the approach to minimize the possibility of encountering wake turbulence. While the best mitigation is to avoid the threat completely, oftentimes the flight is of such priority that other forms of mitigation are necessary. During flight, pilots should continue to be aware of emergent loss of control in flight threats. By staying aware of possible situations conducive to a loss of control in flight, they are more likely to recognize the early stages of a loss of control in flight event. Early detection greatly enhances the likelihood of preventing an upset. This awareness is especially important during flight with the autopilot engaged. While autoflight is often the time when a pilot will assume a lower level of vigilance, in the presence of loss of control in flight threats, such a relaxed attitude can lead to a sudden upset. The autopilot will attempt to keep the aircraft within the desired state, using more and more of its control authority. If the limits of authority are exceeded, most autopilots will disengage, suddenly allowing the controls to return to neutral in most aircraft. The counter-upset control inputs previously held by the autopilot will be removed, and the aircraft may rapidly be placed in an upset condition. A vigilant pilot would notice the increasing displacement of the controls from neutral as the airplane attempts to maintain its state. In such an instance, it may be prudent to assume control from the autopilot to prevent the situation of experiencing a disconnect with no pilot on the controls. A further byproduct of an active awareness of loss of control in flight threats is that the pilot is less likely to be startled should an upset occur. A pilot that is unaware may have as much as twice the reaction time as that of a pilot that is aware of the potential need for intervention. Minimizing reaction time in a loss of control in flight recovery event is essential. Joint research by NASA and Boeing determined the window of opportunity available to resolve an airplane upset is often less than 10 seconds to initiate correct recovery action. With this potentially limited recovery window, pilots should constantly remain vigilant and aware of active mitigation of loss of control in flight threats. In conclusion, loss of control in flight continues to be the greatest threat of fatality in commercial aviation. The emergence of threat and error management has provided pilots with a valuable tool in identifying and mitigating threats and minimizing their impact. It's incumbent upon pilots to utilize all the available tools to achieve the desired outcome of a safe flight. The application of a TEM methodology to the loss of control in flight threat has the potential to greatly decrease the loss of control in flight mishap rate through better awareness of the threat, enhanced vigilance in its presence, and a more rapid response should it strike. Again, we talked about the risk, what is UPRT, what is TEM, and how we can integrate TEM and UPRT to provide greater aviation safety in mitigating the loss of control in flight threat. If you have any questions, feel free to contact me.
APS specializes on the delivery of upset prevention and recovery training for pilots of all skill levels to dramatically reduce the loss of control in flight threat. We offer online, on-aircraft, advanced simulator, train the trainer, and integrated upset training solutions. Please visit us at apstraining.com. Thank you for your time today.